All right, continuing on with some more periodic table organization and training. All right, so I just want to point out some really useful information on your periodic table. And again, this is in your lab guide. So I recommend having that open when you take tests and quizzes throughout this unit. All right, you're not expected to memorize all of this. You're expected to be able to have the periodic table open in front of you and use it to remember these patterns. All right, so first important thing to look at is your key down at the bottom here. All right, so something that is written in black, the symbols written in black, means that at room temperature, that element is solid. If it's written in blue, at room temperature, that element is liquid. All right, so bromine is one of them. What's the other element that's a liquid? If it's written in red, it is in gas at room temperature, and then the green ones are not found in nature, aka man-made. All right. All right, the next is just to talk a little bit more about what happens across periods. All right, so you can notice a couple of things. The atomic number is going to increase as you go to the right. All right, you can see that. All right, we're going from 19 to 20 to 21 to 22 to 23. All right, there's also, when it comes to the elements across the same period, the electrons have the same shell level. All right, or the highest energy electrons. And what that means is looking at your electron configurations, all right, the highest energy electrons end up in the same kind of like outer shell, all right, and that's this 3s, 3p, 4s, 3d. All right, or a shorthand way of even writing those, you can see that these all end with 4s and 3ds. All right, so they end in, all right, looking at groups, all right, again, atomic number increases, but this time the elements share the same properties, all right, whereas with our periods, each element in the same period actually had different properties. And then the elements in the same group have the same number of valence electrons, or the end of their electron configuration is identical, even though it's in a different level. So let me show you what that looks like. All right. The electron configuration for group 2, all right, you can see that they all end with the same number of valence electrons, or in that last shell where the electrons exist, they're all s2s, all right? 3s2, 4s2, 5s2. So you can see it's getting higher as far as the level, 6s2, 7s2. But the very end, or that valence shell, the ones that are in the outermost number, all right, so that highest level, is s2, and a filled s2 shell. So that means that their valence electrons have. The last important key I kind of want to point out to you, and we'll talk about all of these in more detail, but there's additional blocks or additional families of elements that are grouped together. All right, and those have been color-coded with the background color of the slide. All right, so like the dark orange are your alkali metals, the light yellow are transition metals, and actually these guys are even further broken down as being inner transition metals. Not that that's in your guide. Again, we'll talk about what these have in common with each other later. The blue ones are your noble gases, purple are your metalloids. All right, so just kind of know that this key is going to come in really handy as we get into more details. So, based on what we've talked about so far, you should be able to answer questions like these on the right. All right, so for example, name an element in the same period as chlorine. All right, so put any element in that same period. All right, so that means you should be identifying any of these in period 3. All right, so sodium, magnesium, aluminum, silicon, phosphorus, sulfur, argon. All right, so blue matches our answers there. Name an element in the same group as manganese. All right, first thing you gotta do is find manganese, and then you gotta go into your group. And it'd be any of these. So TCREBH. Then name an element with the same valence electron configuration as oxygen. Right, if you recall, it was elements in the same group contain the same valence electron pattern. Right, so again, you got to find group. Sorry, those are right answer there. Make right answer for this in green. So anything in this group 16 or 6A is going to have the same valence electronic pattern.